We're going to do some work with finding the equation of tangents to circles. Okay, first question, we've got a circle given by the equation x minus 4 all squared plus y plus 5 all squared is equal to 40. We've then got a tangent that meets that circle at 2, 1, and the question is asking us to find the equation of the tangent. Remember that tangent's a straight line, so I need point and gradient. I've already got the point, so I need to get the gradient of the line. Okay, so the first thing that I can do here is find the circle centre, which we can see as 4 minus 5. There's then a relationship between the radius and the tangent, and we can see that that relationship is that they meet at a right angle. So I'm now going to find the gradient of the radius, and that will be y2 minus y1 minus 5 minus 1 over x2 minus x1, 4 minus 2. And that's minus 6 over 2, and that's minus 3. I can then use m1, m2 equals minus 1, and specifically in this case, m tan m rad equals minus 1. So m tan, I'm going to flip and invert minus 3, so minus 3 is minus 3 over 1, flip and invert, and that's positive 1 over 3. I've got the point that lies on the line, which is 2, 1, and straight to y minus b equals m bracket x minus a. And that is y minus 1 equals 1/3 bracket x minus 2, multiplied through by 3, 3y minus 3 is equal to 1 bracket x minus 2, 3y minus 3 is equal to x minus 2, bring that over and that will be 3y is equal to x plus 1 as a tangent to the circle. Okay, let's try a second example. Okay, this time we've got a circle like so and a tangent. The point of contact is A14. I'm told that the equation of the circle is x squared plus y squared plus 10x minus 2y minus 19 is equal to 0, and I'm wanting to find the equation of the tangent. Okay, so I'm going to half invert. That means the circle centre is minus 5, positive 1. I then can find the gradient of the radius. y2 minus y1, 4 minus 1, over x2 minus x1, 1 minus 5. And that's 3 over 6, which is 1/2. M tan times m rad equals minus 1. Flip and invert, and m tan then is equal to minus 2 over 1, that's minus 2. There's the point that lies on the tangent. Y minus b equals m bracket x minus a. That's y minus 4 is equal to minus 2 bracket x minus 1. Y minus 4 equals minus 2x plus 2. And that's y equals minus 2x plus 6. Final answer. Okay, next question. We're going to find the equation of the tangent to the circle at a point p5 minus 1. And the circle is given by the equation x squared plus y squared minus 6x plus 4 is equal to 0. Okay, so the circle centre will be 3. We can see that there's no value for y, so that must be 0. So minus 6, change its sign in half, it's 3, 0, half it and change its sign, you get 0. That's 3, 0. Okay, let's sketch out what that might look like then. So we've got a circle centre 3, 0. And the point lies on the tangent, which is 5 minus 1, and I'm wanting to find the equation of the tangent. So first of all, I'm going to find the gradient of the radius. So m rad equals minus 1 minus 0 over 5 minus 3. That's minus 1 over 2. M tan M rad equals minus 1 equals minus 1. Flip and invert, and M tan then will be equal to positive 2. There's the point that lies on the line. Y minus b equals m bracket x minus a. Y minus minus 1 is equal to 2 bracket x minus 5. That's y plus 1 is equal to 2x minus 10. And y is equal to 2x minus 11. Okay, next question. We're going to find the equation of the tangent to the circle x squared plus y squared plus 10x minus 2y minus 19 equals 0 at the point where a is 1, 4. Okay, the circle centre will be minus 5, 1. Okay, so let's find the gradient of the radius. So m rad will be equal to 4 minus 1 over 1 minus minus 5. That's 3 over 6, and that is 1/2. M rad M tan equals minus 1. So M tan flip and invert will be minus 2. There's the point that lies on the line. So that's going to be y minus b equals m bracket x minus a. Y minus 4 equals minus 2 bracket x minus 1. Y minus 4 equals minus 2x plus 2. And y is equal to minus 2x plus 6. The question then goes on to a part B. And the part B then says, show that this tangent is also a tangent to the parabola y equals 2x squared minus 10x plus 14. Okay, so we've got another curve, and we need to prove that tangents exist. So for tangent to exist, we'd have one point of contact, so we can make y equal to y. 2x squared minus 10x plus 14 is equal to minus 2x plus 6. Let's make the thing equal to 0. 2x squared minus 10x plus 14 plus 2x minus 6 is equal to 0. Let's tidy that up. That'll be 2x squared minus 8x plus 8 is equal to 0. Now we can prove that tangent exists by employing the discriminant to get a value of 0, or we can factorise to get equal roots. So we're going to go down the line of trying that. Take out a common factor, which is 2, so that's 2 bracket x squared minus 4x plus 4. Close the bracket is equal to 0. That's 2 bracket x minus 2 all squared is equal to 0. Equal roots, one point of contact, x equals 2, therefore tangency exists. So we can see that the x equals 2 comes across from moving the minus 2 across from the equal sign. Okay, now to find the y coordinate of the point of contact, we then sub into an equation that starts with y. So there's one there. So we're going to sub x equals 2 into an equation for y. And that will be y equals minus 2 lots of 2 plus 6. That's minus 4 plus 6. And that is equal to 2. So the point of contact then is 2, 2.